Okay, so this type of question we're looking at is implicit differentiation. And then we're gonna go ahead and figure out some stuff. Okay, I give you guys 3 questions to work on through Schoology, and they're similar to these types of questions where you have to take the derivative or find the slope or tangent line and write the initial equation. So those are posted along with the rubric. So if you guys want, after this, when you guys are working on your own, I've separated into the question followed by the rubric, so you can do the questions first and then check it. Each of the AP questions are worth 9 points each. Um, at least that's how it was graded before. I'm not sure how the new one will be, but definitely you're still time constrained. Um, and there's only 2 questions on the new AP exam, and we only go up to Unit 7, which is pretty much where we left off on differential equations, okay? Like slope fields. So let's go ahead and go through these problems here. And if you have any questions, go ahead and ask me to stop, raise your hand, or type in the chat. Okay. So we're given a problem. Consider the curve x squared plus 4y squared equals 7 equals to 3xy. And we're going to show that the derivative would be this. So really all they want is to just take that derivative. And if I take the derivative with respect to x, because they told me dy over dx, so let's go ahead and take the derivative here. That's going to be 2x, and then the derivative of x is 1, so I don't need to write that. So it's a very typical derivative. Plus, looking at the 4 is a constant. Y squared is 2 power rule, bring down the 2, bring down the 1, write down the y, write a 1. You don't need to write the 1. 2 minus 1 is 1. And then what's the derivative of y? dy over dx. If you look at the answer sheet, they just wrote y prime, which actually saves a lot of time. And really, you can write dy over dx, you can write y prime. They're synonymous for us. So just write y prime equals to the derivative of 7 is a constant. And then we're going to use product rule because of the xy. So I'll say derivative of the front, leave the back alone, plus the derivative of the back, leave the front alone. That's how I take the product rule. They write it slightly different here, the order, but it is the same thing. Rewriting it, 2x plus 8y, y prime is equal to 3y plus 3xy prime. Now, whenever you see problems like this, you see that the y prime is on different sides. So we want to move them to the same side. Let's move them to the left side. So we'll say 8y, y prime minus 3x, y prime is equal to moving the 2x over, 3y minus 2x, factoring out the y prime, and that's how we isolate it, very similar to a lot of stuff you learned in Algebra 2. 3y minus 2 on the right side. We just divide this whole parentheses to the right. And divide this parentheses to the right. Y prime is equal to 3y minus 2x over 8y minus 3x. Okay. We showed all the work? Yeah. So you get points for first doing this implicitly, meaning you don't separate the x and y. You leave it as it is and you take the derivative of it. Now we couldn't separate the x and y here because of the x times y. So we would have to have done this implicitly anyway. If you'd done it any other way, they wouldn't have given you the credit. Second is that they want you to solve for y prime. There is no rule as the arithmetic when it comes to plugging constant numbers, so you actually have to move it over. One of the things that they ask us is to solve here for dy over dx. So to answer that question, you have to show that. Okay, let's look at part B. Let's give ourselves some more space. Oops. Okay, the next question is show that there is a point P with an x coordinate 3 at which the line tangent to the curve at P is horizontal. So a tangent line, we want it to be horizontal. Now for a tangent line to be horizontal, something that's jumping in my mind already if a tangent line to a curve is horizontal, what is the slope of that curve? Slope is going to be 0. So another thing I always do, whenever I hear the word tangent line, I always think of this idea of y minus y1 is equal to m, x minus x1. I'm just thinking that all the time. So show that there is a point P with the x coordinate 3. So we want a point P is 3 comma whatever that y value is, at which the tangent line to the curve P is horizontal. So we're looking for m is 0. Find the y coordinate of P. So since we are given this equation for the slope dy over dx equals to 3y minus 2x over 8y minus 3x, we're going to be asked, hey, when is this derivative equal to 0? And one of the tricks that we want to make sure is that whenever we see a fraction, when this goes to 0 is when the numerator goes to 0, not the denominator, only numerator. So we can say when 3y minus 2x is equal to 0. So we have x and y value here, and they remember here total x is going to be 3. So we plug in 3 times 2, 3y minus 2 times 3 equals 0, 3y. Moving over, the 3 times 2 is 6, y is equal to 2. So our point P is going to be 3 comma 2. Show that there is a point P with the x value 3, and that the line tangent to the curve P is horizontal there, and find the y coordinate of P. Now let's go ahead and double check this. Dy over dx. Wait, let's see. Oh, let's see if this is actually a point on the graph. If I say plug in x squared plus 4 times y squared equals to 7 plus 3xy. If I plug in 3, that's going to be 9 plus 4 times 2 squared equals to 7 plus 3 times 2. This becomes 9 plus 16. That's 7 plus, that's 9 times 2 is 18. That's 25. It's 25. Yep. So this is the point on the curve. So not only do we have to figure out that the slope would be 0 at 3, 2, but this 3, 2 is actually a point on the given curve. Now, that's so you forgot the second portion here, which is totally plausible. If we look at the rubric on the left, if we get, if we got the derivative equal to 0, that was easy. Bam. That was 1 point. That was 1 point. If we show the slope is equal to 0 at 3, 2, hey, right here, the slope is equal to 0. The slope is equal to 0, right? At 3, 2. That's another point. And if you forget that last portion of showing it that it was part of a line, the good thing is that, hey, this is only worth 1 point. Okay. So don't freak out if you're missing like this one thing. You want to get in as many points as possible. But sometimes if you forget something, it's not going to be 9 points. It's going to be maybe worth 1 point, 2 points. Unless if it's one of those critical errors, it's going to take away all your points. Okay. The last portion of this is find the value of the second derivative at point P. And also determine, does the curve have a local max or minimum or neither at the point? So okay, we said the point P was 3 comma 2, making sure that we have the same point P. Oftentimes on these AP exams, in order to do one portion, you need to do another portion. So just be aware. you could get some points. Like the first part is, hey, what is the second derivative? So if we go back to our first derivative, which is actually written for us, let's find d squared y over dx squared. Okay, so we're going to take the second derivative, d over dx of our 3y minus 2x over 8y minus 3x. So we're going to go ahead and take the second derivative. It's going to be a little fugly, but we'll just have to do it. And the derivative of a rational function, of a fraction, is derivative of the top, leave the bottom alone, and then derivative of the bottom, leave the top alone, over the bottom squared. So we take the derivative of the top, it's going to be 3y prime minus 2, leave the bottom alone, minus the derivative of the bottom is 8y prime minus 3, leave the top alone, 3x, so 3y minus 2x, all over the denominator squared. Okay, that's second derivative. Now, this is good. This is the second derivative. They didn't ask us necessarily to plug in the y prime. We could. Y prime would be a little, messy. We could do that. Now, they did ask us, though, reading the question, find the value of the second derivative at point P. So we now have to plug in the x and y. Now, let me write this in a different pen. We know y is a 2. We know x is a 3. We know y is a 2. X is a 3. We know y is a 2. We know x is a 3. What is y prime, though? Well, y prime was this equation here. So we would have to find dy over dx at 3, 2. Hey, wait, what did we say in part B was my derivative at 3, 2? Wasn't that 0? So without 0, we can say, hey, that's 0, that's 0. These are both 0. So we're left with, I feel like we should have some more easier numbers here. See, it's going to be negative 2 times, that's going to be 16 minus 9. And on the right side, let's see, yeah, we're okay. Negative 3. And we're left with 6 minus 6. And 6 minus 6 is 0. Okay, that all goes away. All over 16 minus 9 squared. Okay. So the reason why the right side went away because 6 minus 6, that's 6 and that's 6, right? Turns out that's 6 and 6. 0 times anything is 0. So we're left with here. Stop here. Don't do any more work. On the AP exam, just a reminder, they don't care that you can do arithmetic. They don't care that you can multiply 2 times 16. They actually prefer you not to do that. They even warn you on the website to not do the arithmetic in case you make a small mistake. If I accidentally add instead of subtract, they're actually going to minus the points. If you want to do the math, sure, since we're not actively doing it, like not taking the test, this is going to be, those will divide out. Leave me one more. So it's negative 2 over 16 minus 9 is 7. Now, since this is the second derivative, if you remember the meaning of the second derivative, the first derivative is a slope. The second derivative is concavity. Concavity. So is this concave up or concave down? This is negative, so less than 0. So this is concave down. And if you remember the rule that if we have a critical point, that's a critical point, and it is concave down, this point is a local maximum. So it fits those two criteria. The critical point is 0, y prime is equal to 0, that's a critical point, and the y double prime is negative, is less than 0, that's a local maximum. Okay, let's look at the rubric to see if we got some points for that. So it's kind of cool. They gave us actually, let me zoom in here. They gave us 2 points if you could set up that derivative correctly. Okay, if you set up this derivative correctly over here without all these red marks. Oops. If you wrote this second derivative correctly, you got points for that. Oops. You got points for that. All right. And then once you plug in the value of that second derivative, you got another point for it. And then the last part is our conclusion, whether it's a maximum or minimum. Okay. So on your homework, kind of similar questions. We're going to just take a look about what they want, what they're asking. First one, hey, implicit. Let's go take the derivative, right? Show that y prime. Next one, find all the points of the curve where the x coordinate is 1, and then rewrite the equation for the tangent line at each of these points. Right, so we're going to write a tangent line equation. That's a y minus y1 equals to m x minus x1. Then find the x coordinate for each where the tangent line is vertical. Now just a reminder, vertical tangent is when the derivative with a 0 on the bottom. Okay, so that's a vertical tangent. So if you look at these problems, they should be pretty much doable, and it's a good practice going back to our second derivatives doing implicit differentiation. We don't know to what extent or the difficulty level of our AP exam will be, but this is a good start into free response questions.